Alright, hello everybody. So I just wanted to do a little bit of math review here. Some of you have requested, and so I'll just provide a little bit of a supplementary discussion around mathematics. So you might notice that there's two handouts. One is the units from scientific notation for musical acoustics, and the other one is a handwritten sheet here called Math Review Sheet. So let's just go over the first one briefly. Some of the questions are exactly handled in the lecture portion, but I just will say, maybe I'll just mark some of these things up here as we're going, is that you definitely will need to know the definitions of some of these units, such as pascals and newtons and other SI units, but you can also figure them out from the context, and so, and we'll say more on that. So some prefixes that are important are milli. This is a 0.001. Another way you can look at that is that, imagine that I had a millimeter. Well, 1 meter would be just a 1, and I'd say 1 point or 1.0. So imagine a 1.0. And if I did milli, that actually means 10 to the minus 3, or it means to move the decimal place over 1, 2, 3. And as I move that over, I fill in with zeros. I like to put a 0 here on the other side just because it helps me. Those little dots can be hard to see sometimes. So that's how we get that 0.001. And maybe writing that a little bit more clearly over here, a millimeter would be 10 to the minus 3. This is the same thing as 1 over 10 to the third, or in other words, this is 1 over 10 times 10 times 10. Let's actually go with one that doesn't have the minus sign just to start with, or should have started with perhaps, is the kilo. So kilo is 10 to the 3, which literally just means 10 times 10 times 10. In fact, that's what the decimal, or that's what the exponential means, is multiply these things by each other 3 times. And that's just going to give me 3 zeros, so that'll be 1,000. And mega will be something 10 to the 6, and that'll be 10 times 10 times 10 times 10 times 10 times 10. So that's actually 6 times, and you'll be left with something which is, you just count the number of zeros, and you'll be left with a million. So if I did that correctly, I have 6 zeros. Good. So that's how we do that. And there's another notation here as well, which is to write something as 1e6. That's actually the same thing. Write a big equal sign here. That looks kind of silly, but there it is. 1e6 is the same thing as 10 to the 6. So I think from that you can probably guess that it means, the e means times 10 to the 6. But let's try another example. What if I wanted to write 54,000? Well, there's a couple of ways I could go about it, but one way is that I could write it as 54 times 10 to the 3. Or I could write it as 5.4 times 10 to the 4, right? So in other words, 5.4 times 10 to the 4, if I bring those decimals over, 5.4, and I bring it over 1, 2, 3, 4, oops, let's speed it down a little bit. If I bring this over 1, 2, 3, 4, I can fill in the rest with zeros, and I'm left with 54,000. But another way to write this would be 5.4 E4. That's another way to write it. So then, it's a compact way, and hopefully you'll see the value of it as time goes on, why we have those 3 different ways. So one thing I want to make sure that you do know how to do is that you can go between this format, and this format, and this format. And all 3 of those things feel good for you. Another thing that I want to say is this minus business. Well, what if I had 5.4 times 10 to the minus 2? Well, this is the same thing as 5.4 times 10 to the minus 2, which really means just taking this decimal and moving it, sliding it over 2 to the left. So that would leave me with 0.054. I'm going to fill in a little 0 in there just to remind ourselves that it is a 0.054. So that 10 to the minus 2, you're going to see as an e minus 2, and that's the same thing anytime you see this to the minus something. So for example, if I had 5 to the minus 3, that's equal to 1 over 5 to the 3. So it really just means bring it down to the bottom. Okay, good. So let's see here. So we need to practice problems, and so for that reason I want to encourage you to take a look over this example 1, calculating some speeds, and example 2, calculating some force. And these are the ways that you can practice. So the joke in there is that the stronger students are the ones with the muscles. It's not really about The brawn, it's about actually developing that brain muscle through actual practice, right? So you don't go to the gym and watch other people work out and then feel like, wow, that was a really great workout. I benefited a lot from that. So we have to practice. So for example, an activity that we might ask ourselves as a question would be like, oh, let's say that I needed to drive to LA and I needed to do it in 6 hours. Okay, well, we could actually just, we could use old Google to figure these kinds of things out, right? So I could say driving directions to LA, and hopefully it says something like that. And so it says 5 hours and 43 minutes or 361 miles. Well, okay, so then maybe I could ask myself, well, then what's actually my average speed? Let me go back to the camera here. So if my distance is 361 miles, and the time that it takes, let's just say that the time is equal to 6 hours for right now. I might ask myself, well, what's my average speed? Well, I need something in miles per hour, right? So I need to think through that one and think, okay, I need to come up with something that's in miles per hour. So I know that speed, and again, I'm going to write that speed as a V. It stands for velocity, and velocity is just a speed with a direction. And that velocity, or speed, is going to be equal to a distance per time, so miles per hour. So I need to do a distance per time. And if we look at that, the units, 361 miles divided by 6 hours, we're going to have on the right side here the miles per hour, and on the left-hand side here we'll have actually a number. That number, I'm going to say, is approximately equal, so I don't have to bust out a calculator right now. 360 over 6 is just 60. So that would be 60 miles per hour is actually going to be my average speed to get to LA. So, does it make sense? I don't know. I mean, sometimes on the 5 you can go a lot faster than 60 miles an hour. But if you consider also maybe traffic, and maybe some stoplights and so on, 60 miles an hour might be your average speed. It might be an appropriate estimate. So there's how, just a nice example of how we can get there. The last page of this handout here is basically recapping some of the things that I just discussed about the 54,000. There's an example there. Make sure that you know how to fill in the blanks on these. In fact, I would recommend that you take the time to go through all of these and, for example, cover up the other two and say, if I have this one, can I write it the times 10 to the? Can I write it as a decimal? Is it making sense? Practice those things and make sure that you've got it. Okay, so that's the catch in this class, is that you don't learn just by simply reading passively, but you've got to try it out. All right. So that's that for now. I am going to move gears. If you have any other questions on the units, feel free to ask. I'll also then talk about this math review sheet here. Some of these properties here, such as the distributive property, these are all variables that I've written here. Maybe I should practice just solving an algebraic equation, just to make sure that that's feeling familiar and comfortable to you all. Let me grab a nice sheet of paper here. So just for example, if I gave you something like x times y is equal to 10, and I said, oh, okay, well, I'm going to tell you that x is equal to 2. What's y? Well, you might be like, well, I don't know, do I have to just kind of keep guessing y's until it works? Well, there's a way to get to this, is isolate the y. So we can divide both sides by x, and then if we do that, we see that the x's cancel out here, and we get y is equal to 10 divided by x. Cool. That means if I just put in this x here for 2, we'll get y is equal to 10 divided by 2, and we get 5. We can go ahead and test that. Here's my original equation, x times y equals to 10. And if I plug in 2 for x, and if I plug in 5 for y, I get 2 times 5 equals to 10. So indeed it works out. So that's just kind of some reminder about how we solve algebraic equations. If you need practice with that, please let me know, and I'll make sure to point you in the right direction. Another thing that's kind of a handy thing is about fractions. And so if you take the reciprocal of something, so if I did 1 over, say, 5/6, that's going to be equal to 6 over 5. So in other words, if you take this in the denominator and you want to bring it up to the numerator, just flip it. So that's pretty straightforward. If I did 1 divided by 1/3, that's just 3. Or you could say 3 over 1, but 3 over 1 is just 3. So I can just say well, that's 3. So that's kind of a nice thing to know. We're talking here about multiplication of fractions. For example, I guess this is already sort of written out here, so maybe it's not worth it for me to write it again, but if I had a fraction a over b and I divide it by c over d, look at how we say it's, well, it's a over b as a fraction times the fraction 1 over c over d. And notice how we flip it here to d over c, so it becomes ad over c. So as an example with real numbers, 5 halves divided by 3/4, here's my 5 halves, and here's my 3/4 in the bottom. Flip it, and then you multiply it, and then the 2's here looks like they're canceling the 4 and the 2, and you're simplifying the fraction into 10 parts. So a hertz is defined as times per second. So what is 1 over hertz? Well, if we did 1 over hertz, which is 1 over seconds, it looks like we're left with seconds. So that's going to be something that we'll see a lot of in the coming weeks. Let's see here, what else is important? Unit manipulations. Okay. So sometimes you're given weird units and you need to convert them into something more familiar. So for example, this example here says I've got something in pounds per square inches, and I need to convert it into newtons per square meter. You might be thinking, well, I don't know what any of those things are. But then you do know what a pound is, so let's start from there. If I'm given a number 10 to the minus 2 pounds per inches squared, and I need to convert this into something newtons per meter squared, well, I better get clear on how many pounds there are in a newton and how many inches there are in a meter. So I'll give you those things. There's 4.5 newtons is equal to 1 pound. Okay, so let's work with that one first. If I need to convert the pounds to newtons, there's a trick here, and I call it the multiply by 1 trick. And if I divide both sides here by pounds, 1 pound, notice how the pounds cancel out, the 1's cancel out. This is just 1 on this side here. Try to draw my 1 so that you recognize it as a 1. So notice now we have 4.5 newtons divided by 1 pound. So in other words, if I took this number here, 10 to the minus 2 pounds per inches squared, if I multiply this by 4.5 newtons per 1 pound, what's cool about this is that the pound and the pound cancels out and I'm left with newtons. So I've essentially multiplied by 1, which doesn't change the number, but now we've changed the units. So this is going to be now 10 to the minus 2 times 4.5, and it'll be newtons per inches squared. So we're halfway there. Now we've got this number here. I'm going to leave all these numbers as they are right now. We'll have newtons per inches squared. Now we've got to convert the inches squared to meters squared. Well, I happen to know that 39 inches is equal to 1 meter. Now, you might think, well, don't we just do the same thing then? So don't we take our 10 to the minus 2, that'll be 4.5, that's 10 to the minus 2, newtons per inches squared, just like that. And then don't I just multiply then by, it looks like I gotta cancel out the inches, so I should put, I'm gonna divide both sides here by 1 meter. So my multiply by 1 trick is going to be to multiply by 39 inches divided by 1 meter, right? That's good, right? It's going to cancel the inches, right? Well, but this is in inches squared here. So we actually need to do it twice. So I could write, again, 39 inches per meter, or I could just say squared. And if I square the outside of something, that's the same thing as squaring everything inside. Even squaring the 1. But, okay, 1 squared is just 1, so we don't need to worry about that too much. But now, our inches squared cancels out. Our meter squared is left, and now I can rewrite this here as 4.5 times 10 to the minus 2 times 39 squared, and this is going to be newtons per meter squared. Notice I didn't write the divided by 1 squared because that's just 1. So finally, we put that all together, you'll find that the number is very close to 10 newtons per square. So anyway, so that's how you solve that kind of problem. This is also worked out in the units manipulations in the handwritten part here. So there's a little bit more discussion around that to remind you, but that indeed is a very important part of this. So the units analysis is kind of a great way to solve problems, especially even when you're not sure how things are working. So if you ever forget a formula, you can probably figure it out just through the units. So for example, one of the equations that you're going to see a lot of is this wavelength times frequency is equal to velocity or speed. And you might think, oh gosh, I forgot which one it is. If it's lambda divided by f or lambda times f. Well, the cool thing is that if you know what the units of each of these things are, so lambda, the length of a wave, is usually in meters, and the frequency is usually in 1 over seconds, or hertz, then you can just say, oh, well, I need something in meters per second. So meters times 1 over seconds is a velocity, is meters per second. So we sometimes write it in square brackets to remind ourselves that it's just in units. We've gone over some powers of 10. One thing that I'll maybe just mention here is that if you're multiplying, say, 10 to the 5 times 10 to the, let's put it in real, so if we do 10 to the 5 times 10 to the 7, the exponents are just going to add. We'll get 10 to the 5 plus 7, or 10 to the 12. If you divide two things, so if I did 10 to the 3 divided by 10 to the 5, this would be 10 to the 3 minus 5. In other words, I get 10 to the minus 2, which would be the same thing as 1 over 10 squared, or 1 over 100. So I want you to practice those, and I'll be glad to provide you with more practice questions if you need them. So I think that's most of the math review. Hope that was helpful, and we'll get lots and lots of practice as time goes on. I want to encourage you to jump into our first homework assignment and see about if this is making sense for you. All right.